Okay, here is some help with some problems that have I. Basically, what's going to happen is I'm going to go over some easier problems that lead up to the problems with I. So let's get started. Let's pretend that you have this equation to solve. The equation is x squared equals 36. Don't forget what this is asking you. It's asking you what number times itself is equal to 36. Now, you might already know the answer to that because you know basic multiplication tables. What number times itself is 36? You think, 6. Well, how do we do it on paper? What does it look like? If you have the square of a variable, you get the variable by itself. You solve for that variable by taking the square root of it. The square root of x squared is just x. So if I take the square root of the left side of my equation, I also have to take the square root of the right side. So if x squared equals 36, then the square root of x squared equals the square root of 36. And the square root of 36 is 6. So that's what it looks like on paper. Just to be clear, you understand why the square root of x squared is 36. It's because they are opposite operations. They're going to cancel each other out. For example, let's just say I had any number 3. If I square it and take the square root of it, see what happens. What is 3 squared? 9. So that becomes the square root of 9. And what is the square root of 9? 3. So, of course, 3 squared, the square root of 3 squared is 3. Any number that you do this to will work the same way. The square root of 4 squared is the square root of 16, because 4 squared is 16, and the square root of 16 goes right back to 4. So, et cetera, et cetera. It also works the other way around. If you have the square root of, let's say, 25, and then you square that, this is, again, opposite operations. The square root of 25 is 5, so that turns into 5 squared, and 5 squared is right back to 25. So anytime you have a square root and a square, they cancel each other out, and you go right back to whatever was under there in the first place. So let's get back to this. This isn't actually all the answer to this problem. We're not done yet. X squared is 36, and the square root of x squared is the square root of 36, but there's a problem. This is not the only number that you can multiply by itself to get 36. You can also multiply negative 6 by itself to get 36, because negative 6 times negative 6 is positive 36. A negative times a negative makes a positive. So how do we account for this when we're solving it? Well, we have to say that whenever you take the square root of both sides of an equation, you're saying that the square root of your variable is equal to the positive or negative version of the square root of the other side. So you have to put this little plus minus symbol. It's a plus and a minus symbol right on top of each other. And that is saying I want the positive or negative version of the square root of 36. The square root of a number is by definition positive, so you have to say positive or negative version of the square root of that. And so I want positive 6 or negative 6, and now there's both of the answers there. So what does this have to do with I? Well, let's do something else first. Let's say that you have the square root of a number like 17. So you got x squared equals 17. Well, the square root of x squared would be equal to the square root of 17. And then you have x equals, what's the square root of 17? That's an awkward number. This is irrational. It's a number that if we put it in decimal form, it would be a decimal that goes on and on forever, never has a pattern, never repeats itself, never stops. And because of that, we just usually leave this written as the square root of 17, unless we're at the end of a problem and we need an actual, measurement. But usually when we're doing these types of things, it's in the middle of an algebra problem, so we're going to keep it like that for now. This is the exact answer. If I was going to write the decimal version of this, it would just be a rounded estimate. You can round pretty far. You can round to 3 decimal places, and that's normally plenty. But for now, we're just going to leave it as the square root of 17 because the square root of 17 has no perfect answer. Now, you should realize that this is a little bit more than the square root of 16, right? So the square root of 17 is greater than the square root of 16, clearly. And the square root of 16 is equal to 4. So the square root of 17 is more than 4, just a little bit more. But at the same time, the square root of, say, 25 is greater than the square root of 17. And the square root of 25 is 5. And 5 is greater than the square root of 17 then. So that means that this number is somewhere between 4 and 5. So 4 is less than the square root of 17, which is less than 5. So if you were going to make an estimate, you would say, well, it's between 4 and 5. And because it's pretty close to 16, it's closer to 4 than 5. But what else can happen sometimes when you have a square root problem like this? Here it is. Let's say you have x squared equals 28. And you're thinking, oh, that's another number that's not a perfect square. That's not a perfect square like 4 or 9 or 16 or 25 or 36 or anything like that. This is higher, and 30, it keeps going, obviously. This is in between 25 and 36. So this answer, x, is going to be the square root of 28, because we're going to take the square root of both sides. And this answer is going to be somewhere between 5 and 6, because 2 squared would be 4, 3 squared would be 9, 4 squared would be 16, 5 squared would be 25, and 6 squared would be 36. So if we're taking the square root of those numbers, the square root of 25, which this would be more than, because it's the square root of 28, it's more than the square root of 25. So it's more than 5, and it's less than the square root of 36, so it's less than 6. So this answer is somewhere between 5 and 6. 5 is less than the square root of 28, which is less than 6. And again, it's a little closer to 5 than it is to 6. But there's another thing that we could do with this problem. Here it is. What perfect squares are factors of the number 28? 28 divides by what of these? It divides by 4. 4 is a perfect square that is a factor of 28. So what we're going to do is we're going to break 28 up. We're going to say x equals the square root of 4 times 7. 4 times 7 is 28. So I haven't really changed anything. I've just broken 28 up into two different numbers like that. Now, why would I do that? Because now I can separate them. We are allowed to write them separately. I could say the square root of 4 times the square root of 7. And now I can actually say what the square root of 4 is, and we know the square root of 4 is 2, so I'm going to say 2 times the square root of 7. And when I say 2 times the square root of 7, I could just put 2 square root of 7. I don't need to put a little multiplication dot or anything. It's kind of like when we say 2 times x, we just write 2x. 2 times the square root of 7 is written as just 2 root 7, like that. So the answer to this problem that I would want you to write is 2 times the square root of 7. That's what I would want if I gave you x squared equals 28. So again, let's see what happens. If you have x squared equals 28, you take the square root of both sides. So you take the square root of x squared and you take the square root of 28. Square root of x squared is x, so that equals the square root of 28. 28 does not have an integer answer. When you take the square root of 28, it's an irrational number. So we're going to break 28 up into 4 times 7, because 4 is a perfect square. Then I could break that up into the square root of 4 times the square root of 7, and the square root of 4 is 2. So this becomes 2 times the square root of 7, and that's the answer I want. Now, I couldn't have done that with 17. Why not? Because 17 doesn't divide by any perfect squares. It doesn't divide by 4 or 9 or 16 or 25 or anything like that. So I could only leave the square root of 17 as the square root of 17. I could not have changed this any more than it was already there. One more quick example, and I'll get to your actual questions. It's just important that you understand this before we move on. Let's say that you have x squared equals, and I will say 22. Well, the square root of x squared then would be equal to, oh, and you know what? I'm sorry, I have to go back because I've forgotten the very first thing I told you, which in the very beginning was you have to say the positive or negative version of all these things, right? Well, of course, then that means you have to do that over here too. This is positive or negative square root of 17. And this is positive or negative 2 root 7. So I apologize, I forgot to say that. But every time you take the square root in a problem, you need to say that it's the positive or negative version of that square root. Always, always, always. Don't forget that. Okay, so let's get back to this last example. X squared equals 22. That means the square root of x squared equals the positive or negative version of the square root of 22. The square root of x squared is then x. And this equals, well, does 22 have a nice perfect answer? Is 22 a perfect square itself? No. We know that this is going to be less than 5 and more than 4. Can I break this up? A lot of kids have the desire to go, oh, yeah, 22 divides by 2 and 11. So it's square root of 2 times the square root. This is useless. Don't do that. 2 is not a perfect square. 11 is not a perfect square. Breaking it up into those two factors does absolutely nothing for you. The only thing we do with this is we say that x is equal to the positive or negative version of the square root of 22. And that's all we're going to do with that. Only divide your number up into factors if one of those factors is a perfect square. So it doesn't matter that 22 divides by 2. 2 is not a perfect square. We can't do anything with the square root of 2, so we might as well just leave it with the square root of 22. Okay, 2 and 11. Neither one of those is a perfect square. All right, so now let's go into the problems that you're actually asking about. What's up with I? Where does that come from? What does it equal? What's all those problems you're getting? Let's say that you're getting another one of these problems, and it's x squared equals negative 25. Now, you should be asking yourself, what in the world, how do we get a negative number when we multiply something by itself? And you can't get a negative number when you multiply something by itself. Not in the real world anyway. There's no real number that you can plug in for x where I can multiply that number by itself and get a negative answer. So this is what we're going to do. We're going to break this number up, just like we did before. I'm going to say that x squared is equal to 25 times negative 1. So that's going to be a little bit interesting. Here's what I do with that. I say the square root of x squared then equals the positive or negative version of the square root of 25 times negative 1. And then the square root of x squared is x. And that would be equal to the positive or negative version of the square root of 25 times the square root of negative 1. Just break them up. And now I could take the square root of 25. So that is positive or negative 5 times the square root of negative 1. So you're still asking yourself, well, square root of negative 1, that doesn't make any sense. That's impossible. And, well, you're right. There's no real number that when you multiply it by itself equals negative 1. But these types of problems have happened so often in math that we've come up with a way to symbolize them so that we can keep working. And here's what it looks like. It's x equals positive or negative 5i. There's the I that you've been asking about. I is always equal to the square root of negative 1. They're the same thing. It's just an easier way to write the square root of negative 1. So whenever you're looking at I, you have to remember that I is equal to the square root of negative 1. Always. Okay, so what can we do with that type of number, the square root of negative 1? What are some properties that it has? Well, I is always equal to itself. I is equal to I. Okay, that's clear. I is I. That's kind of seems like a silly statement. But I is I to the first power. We don't usually write the 1. It's just implied. But let's write it here for example. I to the first power is I. What is I to the second power? Well, I to the second power would be equal to the square root of negative 1 times itself, because I is the negative 1. So is the square root of negative 1 times the square root of negative 1. And if we think about this with any other number besides the negative 1 in there, what if I told you the square root of 4 times the square root of 4? Well, that's going to be 2 times 2. So that's going to be 4. So the square root of 4 times the square root of 4 is 4. And we covered that already, because with the square root of 4 times the square root of 4, it's just the square root of 4 squared. And the square root of 4 squared is 4, because these are opposite operations. They cancel each other out. So if I have the square root of negative 1 times the square root of negative 1, that's going to be negative 1. So I squared is negative 1. Okay, well, what about I to the third power? What's I to the third power? Well, remember that I to the third power can be written as I to the second power times I to the first power. I to the second power means I times I. So this would be I times I, which is I to the third. Well, I squared, we just decided was negative 1. So we have negative 1 times I. And if I had negative 1 times x, you would tell me it's negative x, right? Well, negative 1 times I is negative I. So I to the first power is I to the second power is negative 1. I to the third power is negative I. Let's keep going. Let's go I to the fourth power. Well, I to the fourth power can be written as I squared times I squared. Because I to the fourth power means I times I times I times I. It's 4 i's you're multiplying together. I squared means I times I times I squared is I times I. So I times I times I times I. So there's your 4 i's. And let's not forget that I squared is equal to what? Negative 1. So I squared times I squared is actually negative 1 times negative 1. And what is negative 1 times negative 1? Positive 1, because the negative times the negative is a positive. So I to the fourth power is I squared times I squared, which is negative 1 times negative 1, which is positive 1. So I to the fourth power is just 1. So we've got some funny answers here, but let's keep going. Let's just keep it rolling, see how many answers we get. I to the fifth power. Well, I'm going to think of I to the fifth power as I to the fourth power times I to the first power. We have I to the fourth times I, so we have 5 i's that we're multiplying together. I to the fourth power, we just found out, was 1. So this is actually 1 times I. Well, 1 times I is just like 1 times x. It's just I. 1 times x is x, and 1 times I is I. It's just like any other variable. So I to the first power is I. So is I to the fifth power. That's kind of funny. I to the sixth power. I to the sixth power, then, would be I to the fourth power times I squared. I to the second power. I to the fourth times I squared is I to the sixth. I to the fourth times I to the second is I to the sixth. And again, I to the fourth is just 1. And 1 times I squared is just going to be I squared. Well, what was I squared? I squared we already figured out was negative 1. So this is going to be 1 times negative 1, which is just negative 1. So you might have picked up by now that I to the fourth is 1. And this cycle is just going to continue. I to the seventh power is the same as I to the fourth times I to the third, because 4 plus 3 is 7. I to the fourth is 1. I to the third is negative I. 1 times negative I is negative I. And then you have I to the eighth power. I to the eighth power is going to be I to the fourth times I to the fourth, which is 1 times 1, which is 1. I to the ninth power is I to the eighth times I to the first. So you have I to the eighth, 1 times I to the first, I. So you have I again. And you have I to the 10th. So what's going to happen here, if you haven't figured it out by now, is that you get the same 4 answers cycling over and over and over again. I to the 10th is going to be negative 1. I to the 11th is going to be negative I. And I to the 12th is going to be 1 again. So these same 4 answers cycle over and over and over again. That creates a funny little thing where you could pretty quickly figure out I to any number. Let's say you have I to the 89th power. Well, it's not like you have to keep listing these out. Every multiple of 4 as an exponent is going to be 1, and then you're going to start a new cycle over right after that. So all you have to do is figure out how many times 89 divides by 4. If you have 89 divided by 4, then you have that 4 goes into 89 22 times. I'll write it out for you if you want. 4 goes into 8 twice. 2 times 4 is 8. Subtract, you get 0. Bring the 9 down. 9. 4 goes into 9 twice. 2 times 4 is 8. 9 minus 8 is 1. You stop right here. It goes in 22 times with 1 remainder. So if this was 88 exactly, it would be a multiple of 4, and this would be equal to 1. But it's not a multiple of 4. It's a multiple of 4 with a remainder of 1. So if I had a multiple of 4, like 4, for example, a remainder of 1 would be the very next 1, which is I. So I know that I to the 89th power is equal to just I. If your remainder is 1, the answer is I. If your remainder is 2, the answer is negative 1. If your remainder is 3, your answer is negative I. And if you don't have a remainder, you can't have a remainder of 4. It just would be the next number up. There's no remainders of 4. If there's no remainder, then your answer is 1. And that's what happens for every exponent of I. So again, you can have I to any exponent, I to like the 74th power. Okay, well, what is 74 divided by 4? 74 divided by 4 goes into 7 one time. 3, 34. 4 goes into 34 8 times. 8 times 4 is 32. My remainder is 2. So this is going to be negative 1, because that's what you get when you have a remainder of 2. That's it. That's how I's work when you have when it's asking you what the values are. If it gives you a multiple choice, the multiple choices are either going to be I, negative 1, negative I, or positive 1. And all you have to do to figure out the answer is decide what the remainder is when you divide the exponent by 4, and whatever the remainder is tells you what the answer is. Again, if your remainder is 1, then your answer, if your remainder is 1, then the answer to the problem is that it's going to be I. If the remainder is 2, then your answer is going to be -1. If your remainder is 3, then it's going to be -I. And if you don't have remainder, if the remainder is 0, then the answer is 1. And that is it for that. So if you have other types of questions like that, let me know, and I'll try and get back to you as soon as I can. That's it. Have a good day.